keeping in the line of town. This is one of the early police officers from Lego Town. So now we're going to show you how to use our calculator to perform Gauss-Jordan elimination on an augmented matrix. So first we're going to turn this thing into an augmented matrix. So 2, 1, 1, there's a line, and then 3, 2, negative 2. Recall one row is equal to an equation, and then the columns are the coefficients. So our goal now is to put this into a calculator. So turn your calculator on, hit second x to the negative 1 to open up the matrix menu, and we need to edit a matrix. Now you might actually have empty matrices on this. So if there's anything that says like 2 by 2 or 2 by 3 or all that mess, then just go to edit. Don't fret that there isn't anything in there, and this should be a 2 by 3. Now notice I actually happen to put this in my calculator already. So you tell the number of rows and the number of columns, and then you input your coefficients there. Notice down here we have this 2, 2. That's the index for this particular entry in the matrix. Okay, so now we're going to quit out of that, and we're going to go back into matrix, and now we're going to do some math. And here is the reduced row echelon form, option B, RREF. So we do that, and then we have to select the matrix. So go back to second x negative 1 to pull up the matrix menu, pull up the matrix we entered, hit enter, and there it is. So the calculator has just turned this into a reduced row echelon form for us, and the solution is 4, negative 7. This is a consistent independent system. We have one solution. Okay, let's do another one. Again, we're going to rewrite these things. Now notice M and T is the order we're doing these. So I've got 1, 1, 1. Those are the coefficients of M, N, and T. And then 1, negative 1, negative 1. We like those numbers. We could add these together and we immediately get zeros here and make that row 1. And there's the first 1 in our column. But we're going to let the calculator do all of that for us. Why do work the robots could do for us? So there's our augmented matrix. Go back in, go to edit. I'll just take matrix 2 and do that. Oh, this was from my grad class. Oops. 3 rows and 4 columns. Okay, enter them in. If you notice what happens as I'm hitting enter, it goes by row. By the way, make sure when you're putting in negative 1, you use the negative button, not the minus button. The calculator treats those two things differently, even though in reality they're not. Okay, so now we're going to quit out of this. We're going to go to second x negative 1. We're going to pull up math, and we're going to choose option B, row reduced row echelon form. Notice we could do this manually by swapping rows and multiplying. That feels like it'd be a lot more work than doing it by hand. So select that B matrix, hit enter, and there it is. Ooh, what in the world is this? Okay, so let's write out what we see. And then we have to talk about what's happened here. So we got 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1. Okay, what this tells us is that 0 equals 1. What? That's not true. That means one of these equations is parallel. This is an independent, inconsistent system. So this has no solutions. So you should do this for yourselves. Return back to what you did in 9.2 and do this Gauss-Jordan elimination on example 3, number 9, so you can see what that looks like. Congratulations, I believe you've done most of pre-calc.